Hello, everyone, and welcome to Knowledge Graphs and More, our webinar on enhancing enterprise data value with AI. Before we get started with the event, let's take a quick look at the agenda. We'll start off with a brief introduction to Thorogood, for those that are not familiar with us, before getting right into an introduction of one of our generative AI case studies. We'll start with the traditional approach to building out large language model-based tools, and then add in how knowledge graphs can help unlock some additional business value. To close this out, Ethan will demo a business case where we'll dive further into some of the concepts and technologies that we discussed throughout. To briefly introduce ourselves, my name is Jake, and I'm a data and AI consultant here at Thorogood. I'm joined by my colleague Ethan, who's also a data and AI consultant. We're presenting today out of the US. I'm based out of Thorogood's Philadelphia office, and Ethan out of our Boston office. We both have experience in delivering data and AI solutions for clients, and we're really excited today to jump into LLMs and how it can really help to unlock some additional value. As I mentioned, we're consultants at Thorogood. If not heard of us before, we're a global independent data and AI consultancy with offices in the UK, US, Brazil, India, and Singapore. We work with our clients on solutions across everything data and AI, from end-to-end solution delivery and architecture design to tool training, application support. Our main aim is to help our customers in the right way, combining our expert knowledge of key technologies in our space, a deep understanding of the data that we work with, and a strong business focus to ensure our solutions always deliver value. We often find ourselves working in a few main industries: consumer goods and manufacturing, pharma and healthcare, banking, and insurance. The organizations we work with are usually large global companies, leaders in their respective industries, and key players in the data and AI field. As I mentioned previously, Thorogood is an independent consulting firm, meaning that we aren't tied to use any one specific technology. We have strong capability and partnership working in and conjunction with these technology vendors to make sure that we pick the best option for your specific need. With that, let's jump into a quick refresher on large language models, or LLMs. These are AI models that generate text or other media as an output based on input data, which is typically also text. There's been a lot of hype in recent years around LLMs, and this is due to their ability to seamlessly comprehend language inputs and generate complex and detailed outputs. And so some of the use cases that we've seen them enable include summarizing large volumes of text much faster than a person could. I'll show an example that we've built out with a customer, Oxford University Endowment Management, where we developed a chatbot tool that used quarterly investment reports from funds and businesses as the knowledge base. They've also been useful for increasing productivity. So we've seen this by using LLMs as co-pilot tools for tasks such as programming or writing emails or statements. Finally, they've also added value in terms of extracting structured metrics from unstructured data. So unstructured data being articles or documents, what have you, and outputting it into a table that can maybe be more modeled traditionally like in a relational database or in a data warehouse. I just mentioned Oxford University Endowment Management, or OUEM for short. I wanted to introduce a case study that we did applying generative AI to their investment tools. We have a full other webcast that covers the case in much more detail, but I think providing some context here will serve as a good foundation on what we were considering quote unquote traditional LLM implementations. This will help us better understand where knowledge graphs can come in and enhance these LLM tools, as well as give a common foundation for these topics. So to start, I'll give you a brief intro to OUEM. They're managers of charitable money, mainly derived through the university, Oxford University, for investors who are attracted by a long-term approach to investing. OUM has been really good at managing the money they have under the control. As of the most recent public data, they've returned about 8% annually over the last 10 years, and they manage over £6 billion of assets. Interestingly, about 3/4 of these assets are held across various equity firms. And why is this important? Well, it's because it's not direct investment. OUM allocates their money to these other agents, these other investment funds, who they then trust to invest that money smartly and pass some of that return back. And this is important because each of these different funds will have their own opinion on things. They may have different risk appetites, and they'll invest differently. But what we see come about is that there is an information imbalance here. OUM has to be able to monitor and understand why these funds are making the decisions they're doing. And in order to stay in the loop, OUM will frequently need to ask questions of these intermediaries. And this can include questions like, what's the state of the market? How you think it's going to perform over the next quarter, half a year, year out? To be more other questions like, what's the state of the fund's portfolio? Are they feeling confident? Is it performing well? And do they think it'll continue to perform well in the future? And of course, there's even more specific questions like what has the fund been doing? Have they made any new key investments? Have they sold off any investments? Has there been any change in personnel? All this information is helpful for OUM in understanding the state of the market. When we think holistically about how OUM might try to answer these questions, there's a couple of different data sources that they can tie in. One is a traditional quantitative data model, what you may consider like a data lake or data warehouse. Thorogood has helped design and evolve over the last 15 years, a quantitative data model. And this is where you store quantitative insights like raw performance numbers, the exact details on the investments that the funds have been making. There's something missing from this purely quantitative side. And this is where the LLMs, this is where they start to fit in. And this is because a lot of the information that we're looking for is taken from quarterly investment reports that they receive. Over OUM's lifetime, they've received about 10,000 of these proprietary reports, each of which contains information that can help answer these questions. This kind of information is incredibly useful and valuable to OUM, and we were hearing that there was a need to better use this data. What we heard in the past was that the analysis of the reports was very time-consuming, and the extraction relies solely on the human analyst. So it requires somebody with the know-how to find the correct information among thousands of reports, extract that information, and surface it appropriately to the rest of the team. Naturally, we worked with OUM to come up with goals that any solution addressing this need should meet. And so here were some of the goals that we outlined. The first was to add AI-powered insights to the human interpretation. And we all know that this tech space is developing quite rapidly, and there was a real sense like something could be done to supercharge the investment team's analysis. Finally, we've got the ultimate goal to amplify the investment team's time. And this isn't replacing the investment team. Of course, they've still got a super useful place in adding their professional insight to the analysis coming out of these documents. This is more so about freeing up their time to move it away from manual tasks such as searching these reports and moving them on to tasks that have a higher value return. I'll jump quickly to do a demo that we've set up on public documents that will help ground the example, help give you an understanding of what I'm talking about here. If you interacted with ChatGPT or any of these large language model tools, this should hopefully look a little bit familiar. We have a question box at the bottom here where you can go and ask any question that we might have of our data. And some additional functionality that we've added on as well are these filters at the top. So maybe you want to look at a specific industry or specific domain. Maybe within that domain, you want to look for a specific company. And within that specific company, you want to look for a specific time. If you know, hey, how is this company doing over 2023 or over the past year? This will allow us to easily cut down the context that we're looking for. If I go to ask a question of my data, such as what are Amazon's guiding principles, we'll go ahead and see the chatbot will go and look against our documents and pull out an answer. And I'll return it quite nicely to us in this very easy to understand way. We can go and backtrack and see, okay, these are the documents that we've got the response from. So I can go and click, hey, maybe I don't trust that answer. I want to go double check. And if I scroll down, I can see in this about Amazon, here are the 4 principles. This is exactly where the text is coming from, how the chatbot got the information. I'll go in just a minute on how this is actually working behind the scenes. But I hope this example is helpful in just showing, hey, we've taken our proprietary data, we've thrown a chatbot on top of it, and now we can really start to search and understand and better use all of this thousands of reports, thousands of documents that we have to help the search process. I'll jump back to the slides now. And if we think about how a person might build this or how we might build this, I'll walk through an architecture more generally of how we built out a Retrieval Augmented Generation, or RAG or RAG. You may have heard of these terms. But basically all this means is we're using our documents to augment the retrieval for the chatbot. This has been super simplified for the purposes of this presentation. So do check out our OUM webcast or reach out if you're interested in the finer details. With that, we've got thousands of documents. And our first step is to bring all of these documents into one place in our data lake. And this will allow us to build on top of it. We then break out the text into more useful chunks. So we break out the text, the sections, the tables, and we can use some of the out-of-the-box tools like Azure AI Document Intelligence Studio to make this process repeatable and scalable. So this is really getting the documents out of the PDF format into something more usable. And then we add in the powerhouse of the solution, which is something called the search index. This will allow us to store our broken out text chunks and organize based on keywords or by semantic meaning. You may have heard of vector database or vector search, and this is what allows for that searching based off of meaning. From the search index, we then build our point of entry. So we can build the chat interface that we just showed. And at this step, we'll do some API calls to your favorite large language model, whether that's OpenAI, Cohere, Llama. We give it a system prompt to orient the tool, and then use the LLM capabilities to answer the questions based off of our input data. In totality, this is what we call a traditional retrieval augmented generation, which you might have read about elsewhere. So this is the setting up the ingestion part of our architecture. Let's talk a little bit about our retrieval. So what happens when a user asks a question? So the first step is to create a search query from my user question. And what we'll do is we'll compare that search query against our index text. And this will do either a keyword search or a vector search, which will check how similar my question is to our stored text documents. And then it'll retrieve a score. So for every text document in our repository of all our data, we'll get a score for how similar each text chunk is to my question. We'll rank the chunks based on the scores, and we'll take the top chunks and return that as context for the model. And so this, combined with the system prompt, which is passed to the model every time we ask a question, will allow the chatbot to have an input system prompt, have documents that are relevant to the question, as well as the question. The chatbot will take all three of these things and use it to formulate a response. And I know I've mentioned prompting quite a bit here. So just to show you an example of what's actually going on underneath the hood, what you can see on the screen here is a combination of the system prompt, the top chunks that are retrieved from my search query from before, and then finally the user query. All three of these things are combined and fed to the model as context. And this is what allows the chatbot to dynamically answer a question, to get any question, look up to our database, and return the relevant text content to our answer. And if we walk through some of the strengths and limitations of this approach, it's been mostly very effective in dealing with these business goals. It's been helpful when you have a simple question or you have a piece of information you want to look for, you can very quickly ask a question and get a response back. And this works well for situations where information is stored directly in a paragraph or in a text chunk, like a metric or specific phrase like we saw before. There are some situations where the system has room for enhancements. The current approach is potentially limited in understanding the entire data set. So each response is limited in terms of only getting past the most relevant text chunks. And it's powerful, works for most cases, but it doesn't really understand the entire universe of our data. It's not built into the architecture by default. Additionally, the chatbot only has access to the text chunks themselves. It doesn't necessarily understand how the concepts in the text chunk apply more generally. All it gets is whatever's in that retrieval window that we pass it. When we think about what's going on behind the scenes of the architecture, it doesn't really match how a person, like a business analyst, would go about this task. And if we take a step back, if we think about how an analyst would try to approach a global reasoning question, like how are Microsoft partners using Copilot, the analyst would first look for metrics, identify the broader market environment, maybe ask some additional questions based on that information they found so far, and go back for more info. So it's not just a linear process of, oh, I'll find the top documents, I'll find the top paragraphs and throw that in, and boom, there's my answer. It's much more involved process of trying to understand the relationships in our data. Finally, we may have to go through this process a few times to get all of the information, but the analyst would then synthesize an answer with all of their context in mind. And if we do this in a very small example, a very small scale from a Microsoft document, we have a text chunk talking about Copilot, some of Microsoft's new AI features and adoption rates. The first step in analyzing this would be to look for the key facts, the key things we care about. I've gone ahead and done that, pulled out some of these metrics that we care about. And obviously for this very specific example, there's not that much we're pulling out. But if we were to start to draw these relationships between the different concepts of, hey, I have a text chunk, how can I understand the items within it? It would look a little bit something like this. We would have our source document, the companies that are referenced in the article, and the reference to Copilot chat. We throw it in kind of this mind map or this mental map of concepts and relationships. This is called a property graph, is another term for that. And we can understand that the circles here, or nodes in graph vocabulary, represent the entities that we care about, the things that we care about. Then we have relationships, or edges in graph parlance, that give context to how the different nodes are connected. So we can see Shopify uses Copilot Chat, which was created by Microsoft. Finally, we can have additional properties stored on either the nodes or relationships that store additional info about each node. And this is a very simple example from just one paragraph of text. If you imagine we were to do a similar process for all pages in all thousands of our documents, we'd have a very rich interconnected map of concepts, organizations, and metrics. And this would allow us to more closely understand the patterns of relationships within our data rather than just the paragraphs. And as we'll see shortly, our proposed approach involves doing just this, of creating a map of our graph of all of the concepts and relationships within our documents and using that as the basis for our answers rather than just the text strings. Instead of me doing the heavy lifting in this architecture of me manually going through every single text chunk to pick out what's relevant, instead we'll pass it to a large language model that will do the heavy lifting. So I jump back to our architecture setup, but with this time a focus on adding knowledge graphs to our diagram. For the most part, the start and end is the same. We bring data into text chunks to start, and we know that we'll be passing info eventually to the chat interface. This time though, instead of just using a search index, we're going to create a knowledge graph. And this is that pivotal point in the process where we take our documents, pass them to an LLM. The LLM will do the step I just showed previously, where it will go through looking for entities and relationships and pull all of these things out and eventually write it to a graph database. In our example, we're using Neo4j as a graph database software, and you could swap this out for other graph technologies like TigerGraph or Enzo, depending on your architecture. And this will allow us to more closely model our data as things instead of strings. So not just text, but the items of interest within the text. If we go to the flip side now of after ingestion, what happens when we actually ask a question? It's very similar as well. We get an input question and we create a search query. This time though, instead of searching against our index, we search against our knowledge graph. And this will allow us to identify the key concepts and relationships in our data, more so than just the closely matching text. Finally, now that we've retrieved the entire context of the graph section, the text, key concepts, relationships, properties, anything else that the LLM pulls out as interesting, we return all this as context for the chatbot with the idea that this will allow for a more holistic, a better answer than just returning the paragraph or text chunk. With that, I'll pass it on to Ethan to show a working demo that we have using this new architecture.
Thank you so much, Jake. Like Jake said, I'm going to walk us through right now a demo showing how knowledge graphs can add some improvement on your LLM applications. And so you can see right here, one PDF from Microsoft. This is their 2023 annual report. And don't worry about reading this too closely if you can. It's just to show the example. But this is an 85-page report. And so you can imagine that if you are a business analyst and your goal is to take this report and figure out what sorts of partnerships is Microsoft doing with Copilot, it might be very difficult to go through and read this entire document. You might imagine that a business analyst actually could Command F or search through and find instances of Copilot. And this is very similar to the way that we've seen with these traditional RAG applications that we're having the LLM perform on this data. It's searching through, it's finding relevant text, and then it's using that text to give you an answer. And so if we look over into Neo4j Bloom, and like Jake mentioned, this is a way to visualize our graph documents. We've actually taken that 85-page Microsoft report and we've made it into a knowledge graph. And so first I'm going to walk through a little bit how this knowledge graph was constructed. It's going to be very similar to what Jake mentioned, but you can actually see here how it looks in practice. So we've taken that document, we've passed the text to the LLM, and we've had it extract out those entities and those relationships. Like Jake mentioned, those entities are going to be those important pieces of information, often proper nouns or important concepts or technologies. And the relationships between them, we can look right here. What we pulled up right now from our knowledge graph is one entity of Azure OpenAI service, right? This is just one entity. We can see it described here. And we can see that it has relevant neighbors, right? And these are other entities that it has relationships with. So one of them is Epic. Epic is a company that provides electronic health record systems and will integrate DAX Copilot into its system. And you can see the relationship between Azure OpenAI Service and Epic is that Epic is going to be using Azure OpenAI Service. And so, this is just one example, right? We've used one Microsoft annual report and we've put it into a knowledge graph. But you can imagine how if there are many documents and we have structured and unstructured data, you could actually have relationships from Azure OpenAI Service to Epic and then retrieve information about Epic that doesn't actually mention Azure OpenAI Service. And that allows us to use knowledge graphs to create much more intelligent LLM applications. And one of the important things that this enables is an iterative approach to discovering information versus just searching for it. And what we've seen in the past with these traditional RAG applications is they're very good at having search, but what we want to get into using knowledge graphs is discovery. And so if you're able to find this node from the question, right, you can find the Azure OpenAI service if it's very similar to your query, but you're not going to know to search for information about Epic until you see that it's related to Azure OpenAI service, right? There could be some completely unrelated document that mentions Epic that has very important information that you wouldn't ever know to search for until you know that there's that relationship there. And that's what this knowledge graph enables. And now what we're going to look at is one example of using this knowledge graph to answer a question. So we have right here, you can read our question, how are Microsoft partners using Copilot? And what we've run right here is a regular RAG application. And I'm gonna talk through a little bit. I mean, Jake already talked through a little bit of how it works. It gets the documents, it synthesizes the answer. It searches through that text document for similar pieces of text as to how our Microsoft partners using Copilot, and it provides an answer. And if you can't read this and it's too small, that's totally fine. I'll summarize it very quickly for you. It gives a very good answer directly mentioning Copilot, talking about how its support agents are using Copilot in Dynamics 365 customer service, which is a very, very good answer. It gives specific information, but there might be second level information, right? Relationships between Copilot and other entities that it might not be able to retrieve just by the nature of the architecture. When we look at our response to graph RAG, right? So what this chain right here is doing, we've taken our question, we've searched on the entities and the relationships, not just the text itself, but the entities and relationships, right? If we go back here to Neo4j Bloom, right? As opposed to searching just on the text, we're actually making that search about Copilot on the entities, right? And then we allow the LLM to decide to traverse along relationships to get additional rich information about Copilot, Azure OpenAI Service, Microsoft products, and the partnerships with other companies. And we can see that actually our graph RAG model response in this situation, it returns information about Epic. You can see there is a trade-off here with time, right? Sometimes it does take a little bit longer than it would with a traditional RAG, but that's what it takes to get irrelevant information. So here we see healthcare, the DAX Copilot, it's involved with Epic, right? It was able to retrieve that information, but it wasn't able to here. And there's some trade-offs that we'll talk about. One is that there is a longer time with this because it's doing more complex retrieval. However, if you were to have this response, even though it's 8 seconds more, trust in the application for an actual business analyst is imperative, right? If you actually trust this information, you'll take the 8 extra seconds to get a more accurate answer, to get a more helpful answer. And so you can see here, it has specific examples. It was able to intelligently retrieve. And that's because the LLM is actually playing a role in that retrieval process and not just in the summarization. I'm going to throw it back to Jake here to wrap up.
Thank you, Ethan. I'll wrap it up with just a few takeaways and key considerations. So first, as Ethan mentioned, we have a lot more going on underneath the hood. By creating a graph from just our text documents, we can allow for better retrieval for our chat agents. This adds additional functionality, but adds additional LLMs into the process. So it might take longer, might add more complexity, and might be a little bit harder to understand what's going on in every single step. This also has additional consideration of cost. So as we use LLMs more, there'll be additional one-time costs in terms of creating our graph structure, as well as incremental costs during our retrieval process. So we might not just do one search against our knowledge graph, but the chatbot might decide, hey, actually, I don't have enough information here. Let me go and get more. And that will obviously have a cost impact. And as we weigh up options on which architecture to use, the traditional versus this knowledge graph enhanced approach, incorporating knowledge graph into LLM tools is still very much a developing area. So most cloud vendors don't support it out of the box, and it will require additional expertise to implement successfully. And so with that, we've come to the end of today's session. We hope you found this useful. Thank you all for joining. Have a nice rest of your day.